Hi, my name is Norbert Marta. I am an agricultural engineer currently teach in a secondary school. Last time I told about the importance of the sun in the plant, animal and human life. In this chapter, I will introduce you the history of using solar energy from the beginnings till the present days and also say a few words about the future potentials. I have divided this topic into three parts, following the classical historical areas. So let's start our journey in the history of using solar energy. How we got from grain drying to the modern solar panels. First, let's have a look at following expressions and their meaning: non-renewable energy and renewable energy. Non-renewable energy comes from sources that will run out or will not be replenished for thousands or even millions of years. Most sources of non-renewable energy are fossil fuels, like coal, petroleum, natural gas. The main element in fossil fuels is carbon. Once plants, algae, and plankton grew in these ancient wetlands, they absorbed sunlight and created energy through photosynthesis. When they perished, the organisms drifted to the bottom of the sea or lake, but the energy was still stored in the dead plants and animals. Over the times, the remains were crushed under the seabed. The fourth non-renewable energy is a nuclear fuel, U-235. Uranium, which is used in nuclear power plants, is a non-renewable resource. This type of uranium is a very rare one. When coal, natural gas, and oil are burned to produce energy, they emit heat-trapping gases such as carbon dioxide. This process of trapping heat is what drives climate change, and the failure to address this problem is what's catalyzing the current climate crisis. Over the last 150 years, humans have been responsible for the vast majority of the increase of these gases in the atmosphere, and the burning of fossil fuels is the largest source of these emissions. Nuclear energy also produces radioactive material. Radioactive waste is extremely toxic and causes serious diseases, like cancer. Now let's see what renewable energy is and what kind of renewable sources we have. Renewable energy is the energy that is collected from renewable resources, which are naturally replenished on a human timescale, such as sunlight, wind, rain, tides, waves, and geothermal heat. Renewable energy, often referred to as a clean energy, comes from natural sources or processes that are constantly replenished. At the national level, at least 30 nations around the world already use renewable energy, contributing more than 20% to the total energy supply. Two countries, Iceland and Norway, already generate all their electricity using solarly renewable energy. In this chapter, we will learn about the usage of sunlight. As written and pictorial articles barely survived, it is difficult to reconstruct the use of solar energy in the prehistoric age. In these times, the energy of the sun wasn't directly used by people. The sun has been an object of veneration in many cultures throughout the human history. In many prehistoric cultures, the sun was thought to be a solar deity or other supernatural entity. 6,000 years ago, Chinese villagers had the entire opening of their homes face south to catch the rays of the sun and warm the houses. Some 4,000 years ago, the Chinese scientists began to study the movement of sun. Knowledge gained from these studies stimulated Chinese urban planners to construct the main streets of towns to run east to west, to allow every houses to look to the south in order to catch the winter sun for supplementary heating. If you happen to travel to China, you can see the long streets that run from the east to the west. Ancient Egyptians had already known how to use solar energy on a large scale to heat their homes. They designed their houses to collect and store the sun's heat inside the building's wall during the day. After the sun went down, the accumulated heat would be released in a way that it would regulate the temperature of the homes during the cool desert nights. The sun also was used to dry grains and other agricultural products exactly like nowadays. In addition to this, the sun played an important role in the religious life of Egyptians. One way to preserve food was salting. The coasts of Egypt are connected with the salty sea, so it was easy to create ponds which were filled with salty water from the sea. After some days, the water was evaporated by the sun and the clear salt remained. Nowadays, you can still see this technology in the countries located next to the sea. In the ancient times, the Greek Aristotle taught his students how to use the sun to heat houses during the winter and to keep them cool in summertime. Ancient Greek builders followed his advice, and the influence of this knowledge could and still can be seen in Greece and surrounding countries. In the 1st century BC, the Greeks made history not only with using solar energy for domestic comfort, but also as a weapon of mass destruction. Earlier, people recognized as well that the focused sun is able to cause fire. Archimedes of Syracuse was a Greek mathematician, physicist, engineer, inventor, and astronomer. He is credited with designing innovative machines, such as his screw pump, compound pulleys, and defensive war machines to protect his native Syracuse from invasion. In 220 BC, the Roman enemy attacked Syracuse on wooden ships. Archimedes used the reflective properties of bronze shields to focus sunlight and to set the wooden ships of the Romans on fire, which were besieging the city. Marcus Vitruvius Pollio, commonly known as Vitruvius, was a Roman author, architect, civil and military engineer during the 1st century BC, known for his multiform work entitled De Architectura. When he was on military duty in Greece, he noticed that the houses faced to south. In his work De Architectura, he emphasized the right orientation of houses and baths. In the Roman time, the people covered their large windows with transparent stone or clear glass to keep warmth inside. This was an invention of the 1st century EC, one of the great breakthroughs in building and solar technology. Transparent materials act as a solar heat trap, admitting sunlight into the desired space and holding in the heat so that it accumulates inside. For at least 2000 years, people have attempted to assign solar rights in fair and efficient manner. Ancient Romans protected the right to solar heat and light through respective easements, government allocations, and court decrees. And now it is a quiz time. I have talked about the renewable and non-renewable energy. You might choose the renewable energy sources. Wind. Yes. Coal. No, it isn't. Geothermal heat. Yes, it is. Petroleum. No. Natural gas. No, it isn't. Sunlight. Yeah. Waves. Yes, it is. Solar energy in the Middle Ages. After the collapse of the Roman Empire, Europe sank into darkness. In the early Middle Ages, the technologies did not develop at all. Even previous achievements were forgotten and disappeared. Innovation started to boom again with the beginning of Renaissance. This area is the bridge between the dark Middle Ages and modern history. I think everybody knows the most famous Renaissance man, Leonardo da Vinci, the Italian polymath. It's widely known, it's widely known that he had painted the Mona Lisa and the Last Supper, but he is revered for his technological ingenuity as well. He conceptualized flying machine, a type of armored fighting vehicle, concentrated solar power, and adding machine and the double hull of many others. Now you see the illustration's concave mirror solar concentrator. As we know, the sun has lots of energy. More solar energy reaches the Earth in 1 hour than humanity would consume during a year. Solar energy in the age of discovery. Until the age of discovery, the glass was not used to trap the energy of sun. The rich planned to grow newly discovered tropical fruits, so they built greenhouses which were heated by solar energy. The greenhouses faced to the south and were covered with transparent glass to allow and ensure heating. The early greenhouses were plagued by poor building materials and construction techniques and required quite a bit of work to use. In the early 19th century, builders had developed more efficient greenhouse designs and construction techniques. Wood, steel, and glass were used for building purposes. Some of the most magnificent greenhouses survived until today. One of them is the Palm House at Kew Gardens, just outside London, which I was lucky to see. The greenhouse revolution took place in the middle of the 20th century. Polyethylene became available. The newly designed greenhouses, hoop houses, were constructed of aluminum extractions, special galvanized steel tubing, or even just lengths of steel or PVC water pipes. Construction costs were greatly reduced. This resulted in many more greenhouses being constructed on small farms and garden centers. The durability of the polyethylene film increased greatly as more effective UV inhibitors were developed and added in the 1970s. These innovations extended the life of the film from the 1 or 2 years up to 3 and eventually 4 more years. Nowadays, you can see different types of greenhouses all around the whole world. Horace Benedict de Saussure was a Genevan geologist, meteorologist, physicist, mountaineer, and alpine explorer, often called the founder of alpinism and modern meteorology, and he is considered to be the first person to build a successful solar rover. He wrote, "It is a known fact, and the fact that has probably been known for a long time, that a room, a carriage, or any other place is hotter when the rays of the sun pass through the glass." In 1767, Saussure constructed the first known Western solar oven, trying several designs before achieving a well-insulated box. Source's box was built from wood, insulated with black cork, and its top covered with glass. He placed a similar but smaller glass-covered box inside. When he tied the box toward the sun, the highest temperature in the inner box reached 110, which he found did not vary significantly when the box was carried from the top of Mount Cremont in the Swiss Alps down to the plains of Cournier, some of 1,469 meters lower in altitude and 1 Celsius warmer in temperature, thereby establishing that the external air temperature played no significant role in the solar heating effect. The age of Industrial Revolution. The Industrial Revolution, now also known as the First Industrial Revolution, was a transition from old to new manufacturing processes in Europe and in the United States. It began in the 18th century. The Industrial Revolution marks a major turning point in history. Almost every aspect of daily life was influenced in some way. In particular, average income and population began to exhibit unprecedented sustained growth. As a result, energy demand increased sharply. In India, W. Adams developed an octagonal oven with 8 mirrors which cooked rations for 7 soldiers in 2 hours. It was made from 8 silvered glasses placed symmetrically and formed into an octagonal shape. In the middle, there was a glass-covered wooden box with the sunlight focused on it, so that it heated the food which was put in the box. It was the first mass-manufactured solar oven. The highest temperature in the box reached 200 Celsius. The photovoltaic effect. Alexandre Edmond Becquerel, also known as Edmond Becquerel, was a French physicist who studied the solar spectrum, magnetism, electricity, and optics. He is credited with the discovery of photovoltaic effect, the operating principle, solar cell, in 1839. In 1839, at the age of 19, experimenting in his father's laboratory, Becquerel created the world's first photovoltaic cell. In this experiment, silver chloride or silver bromide was used to coat the platinum electrodes. Once the electrodes were illuminated, voltage and current were generated. Because of this work, the photovoltaic effect has also been known as the Becquerel effect. Auguste Mucho, a 19th century French inventor of the earliest solar-powered engine, converted solar energy into mechanical steam power. Mucho was drawn to the idea of finding new alternative energy sources, believing that the coal, which fueled the Industrial Revolution, would eventually run out. In 1860, he began exploring solar cooking, drawing on the work of Horace Benedict de Saussure. Mucho had developed the first parabolic through solar collector, which was presented to the Emperor Napoleon III in Paris. Mucho continued the development and increased the scale of his solar experiments. The publication of his book on solar energy, solar heat, and its industrial applications coincided with the unveiling of the largest solar steam engine he had yet built. Albert Piffret, French engineer, developed the first solar-powered printing press. He was initially an assistant to Augustin Bernard Mucho, who developed the first solar engine, but later developed solar technologies independently of his mentor. The device consisted of concave mirror, 3.5 meters in diameter, centering on a cylindrical steam boiler, which powered a small vertical engine of 300 watt, and then driving a Myronid-type printing press. It was constructed in 1882. Even under semi-overcast conditions, the press operated continuously from 1 p.m. to 5:30 p.m., producing approximately 500 copies per hour of a journal, which was produced specially for the event. It was produced specially for the event with the appropriate name Soleil Journal. The time will come when Europe must stop her mills for want of coal, wrote the Swedish-American inventor John Ericsson. The great inventor and engineer had decided to devote the last years of life to the solar engine. His work on solar engines spanned from the 1870s through the 1880s. Instead of relying on steam, he utilized his version of the heat energy. But Mouchot and Ericsson were driven by the prescient understanding that the access to coal, the predominant fossil fuel of the time, would eventually run out. The petroleum and the natural gas were not discovered yet. Will Lagsby-Smith was an English electrical engineer who discovered that the conductivity of the selenium rods increased significantly when exposed to strong light. In 1876, William Rayleigh and Richard Evans discovered that selenium produces electricity when exposed to light. Although selenium solar cells failed to convert enough sunlight to power electrical equipment, they proved that the solid motor could change light into electricity without heat or moving parts. Charles Fritz, both American inventor, credited with creating the first working selenium cell in 1883. The first rooftop solar array using Fritz selenium cells was installed in 1884 on a New York City rooftop. In 1891, Clarence Kemp, a Baltimore manufacturer of heating equipment, attended a commercial solar water heater he called the Climax system. During this time, many people secured hot bathwater using a wetback wood stove or range in which water was heated via a coiled pipe that passed through the stove. His invention consisted of 3 tanks mounted in a frame under glass on the south side of the roof of house. The tanks were filled with cold water from the water mains, heated by the sun, and then used for bathing or other purposes. Today's modern passive solar water heaters follow Kemp's basic design. The early 20th century. Everybody knows Albert Einstein, who was the German-born theoretical physicist. He received the 1921 Nobel Prize in Physics for his service to theoretical physics and especially for his discovery of the law of photoelectric effect. He published his paper on the photoelectric effect in 1905, which is the emission of electrons when electromagnetic radiation, such as light, hits a material. In 1908, William J. Bailey of Carnegie Steel Company invented a solar collector with copper coils and an insulated box. Frank Schumann, the American solar energy pioneer, built the world's first solar thermal power station in Wadi, Egypt in 1912. Schumann's plan used semicircle-shaped thrust-to-power to 60-70 horsepower engine that pumped 27,000 liters of water per minute from the Nile River to Agnes and cotton fields. His system included a number of technological improvements. And so we arrived to the middle of the 20th century. Russell Schumacher was an American engineer. His specialized area of research was into the behavior of certain types of crystals. Hall, in 1939, discovered the p-n junction. What is the p-n junction? It is a boundary or interface between two types of semiconductor materials, p-type and n-type, inside a single crystal of semiconductor. The p positive side contains an excess of holes, while the n negative side contains an excess of electrons in the outer shells of electrically neutral atoms there. This allows electrical current to pass through the junction only in one direction. p-n junctions are elementary building blocks of semiconductor electronic devices, such as diodes, transistors, solar cells, LEDs. All is generally recognized for patterning the modern silicon solar cell. In 1954, three American scientists, Calvin Soutler Fuller, Daryl Chaplin, and General Pearson, developed solar cell that could convert enough energy to run everyday electrical equipment. The new era of solar cells began. What happened in the middle of the 20th century? Researchers also discovered in the 1960s other photovoltaic materials. This could operate at higher temperatures than silicon, but were still expensive. The cost of solar cells was high and the efficiency was low. They were used in small things, like toys. The first important application of solar cells was in the Vanguard 1. The Vanguard 1 was the first solar-powered space satellite. It used a small array to power its radios. Later that year, Explorer 3, Vanguard 2, and Sputnik 3 were launched with PV-powered system on board. Despite faltering attempts to commercialize the silicon solar cell in the 1950s and 60s, it was used successfully in powering satellites. While the use of solar cells in the space flourished during the 1960s and early 70s, using of solar cells on Earth's electricity seemed distant. On Earth, the primary criteria was price per kilowatt-hour, but it was too high. Dr. Elliot Berman, with the financial help from Exxon Corporation, designed a significantly less costly solar cell. Berman discovered that, while lowering efficiency, using silicon from multiple crystals was much cheaper than using the silicon from a single crystal. The developed brought the price down from $100 a watt to $20 per watt. Solar cells could now compete in situations where people needed electricity distant from power lines. In the 1980s, the first solar-powered aircraft was built by Paul McCready. It flew from France to England. Australian Hans Thorsson drove the first solar-powered car, covering almost 4,500 kilometers between Sydney and Perth in 20 days. It was 10 days faster than the first gasoline-powered car on the same route. During these years, engineers were able to customize solar electric modules to any special electrical need at the site of use. So solar cells enabled each household to use its own solar system. The world's most advanced solar-powered airplane, the Air, flew over Germany in 1996. The wings and tail surfaces of Air were covered by 3,000 super efficient solar cells, the total surface of 21 square meters. Subhendu Gua is an Indian-American photovoltaic scientist. He led the invention of flexible solar shingles, of roofing materials, and state-of-the-art technology for converting sunlight to electricity in 1998. As from the 90s, the price of solar cells has dropped over the years. They have become the least expensive power source for houses which were located away from utility lines. Let's see what happened after the millennium. The world's first commercial concentrating solar power tower was built in Spain in 2004. Its name is the PS10 solar power plant. It has mirrors. Each of them has a surface measuring 120 square meters that concentrates the sun rays to the top of the 115-meter high tower, where a solar receiver and steam turbine are located. The turbine drives a generator, producing electricity. In 2014, the Ivanpah Solar Electric Generating System was opened in the USA in the Mojave Desert. The Ivanpah system consists of 3 solar thermal power plants on 1,400 hectares. Fields of heliostat mirrors focus sunlight on receivers located on centralized solar power towers. The receivers generate steam to drive specially adapted steam turbines' capacity. Solar energy nowadays. However, government initiatives toward increasing the deployment of renewable energy sources, coupled with stringent regulatory measures to limit carbon emissions, will drive the solar cells market growth. As the World Bank says, solar cells have an important and growing part to play in providing electrical services to the developing world. Nowadays, the solar energy is used all over the world. And what happens in the future? The report by the International Energy Agency found that solar energy technologies such as photovoltaics, solar hot water, and concentrated solar power could provide a third of the world's energy by 2060s if politicians commit to limit climate change and transitioning to renewable energy. The energy from the sun could play a key role in decarbonizing the global economy alongside improvements in energy efficiency and imposing cost of greenhouse gas emitters. The strength of solar is the incredible variety and flexibility of application from small scale to big scale. We will use new materials and better technologies. Prices will continue to decrease. Solar cells will be installed in large numbers. The possibilities are endless. Nobody sees the end. Now it is a quiz time again. What are the advantages and disadvantages of using solar energy? It reduces the electricity bill. This is clearly an advantage, since you will be meeting some of your energy needs with the electricity that your solar system has generated. Your energy bills will drop. How much you save on your bill will be depend on the size of the solar system and your electricity or heat usage. Moreover, not only will you be saving on the electricity bill, there is also a possibility to receive payments for the surplus energy that you export back to the grid if you generate more electricity than you see. It depends on the weather. This is a disadvantage. Although solar energy can still be collected during cloudy and rainy days, the efficiency of solar system drops. Solar panels are dependent on sunlight to effectively gather solar energy. Therefore, a few cloudy or rainy days can have a noticeable effect on the energy system. You should also take into account that solar energy cannot be collected during the night. On the other hand, if you also require your water heating solution to work at night or during winter time, thermodynamic panels are an alternative to consider. It can be used in various ways. This is an advantage again. Solar energy can be used for diverse purposes. You can generate electricity or heat. Solar energy can be used to produce electricity in areas without access to energy grid, to distill water in regions with limited clean water supplies, and to power satellites in space. Solar energy can also be integrated into the materials used for buildings. Uses a lot of space. This is a disadvantage. The more electricity you want to produce, the more solar panels you will need. As you want to collect as much sunlight as possible, solar PV panels require a lot of space, and some roofs are not just big enough to fit the number of solar panels that you would like to have. An alternative is to install some of the panels in your yard, but they need to have access to sunlight. It can be associated with pollution. This is a disadvantage. Although pollution related to solar energy systems is far less compared to other sources of energy, solar energy can be associated with pollution. There are some toxic materials and hazardous products used during the manufacturing process of solar photovoltaic systems, which can be indirectly affect the environment. Nevertheless, solar energy pollutes far less than the other alternative energy sources. It is a renewable energy source. This is the greatest advantage. Among all the benefits of solar panels, the most important thing is that solar energy is a truly renewable energy source. It can be harnessed in all areas of the world and it's available every day. We cannot run out of solar energy, unlike some of the other sources of energy. Solar energy will be accessible as long as we have the sun. Therefore, sunlight will be able to us for at least 5 billion years, and according to the scientists, the sun is going to die. We have come to the end of history of the use of solar energy. Thank you for your attention. Next time, Attila Böröc will talk about how solar energy can be converted into heat. Bye bye.